Let us now learn about chemical reactions. This is the first question. How would we even know that a chemical reaction has occurred? We have learned about physical and chemical changes. We know that chemical changes are not easy to reverse. But on this screen, you will see a summary of some of the evidence that would show us that a chemical reaction has actually occurred. Anytime there is a color change, the only reason you would get a color change is if a chemical reaction has occurred. Anytime you mix two solutions together and you get a solid, as you see demonstrated in this picture, that means a chemical reaction has occurred. Anytime a gas is produced when you add two liquid solutions together, or when you add a liquid to a solid, then you know that a chemical reaction has occurred. Or whenever there is an emission of light, or absorption or emission of heat. For example, if you add an acid to water and you touch the test tube, you will feel the test tube as being warm because the reaction is exothermic, which means heat has been released. And that is an indication that a chemical reaction has occurred. Now, how do we write these chemical reactions in chemistry? Let me give you an example. Look at this statement. Methane, and this is the formula of methane, CH4, reacts with molecular oxygen on a gas stove to form carbon dioxide and water. That statement captures what was occurring when you add oxygen to methane, and it tells you the product that you will get from the reaction. But instead of using so many words, in chemistry, we can use a shorthand notation, which we call chemical equation, to represent exactly the same thing. Take a look at this equation. Methane, which is a gas, this G in parentheses means that you're dealing with a gas, is reacted with the plus sign. It's telling you that you are adding the methane and the oxygen together, and the oxygen also is a gas. To give the arrow is pointing in the direction of the reaction. Carbon dioxide, which is also a gas, and water, which is a liquid. So the L in the parentheses is a liquid. On the other hand, if you have S in the parentheses, that means you're dealing with a solid. And if you have AQ in the parentheses, that means you're dealing with an aqueous solution, which means that something has been dissolved in water. However, something is still not right. What is not right is the fact that all ordinary chemical reactions will obey the law of conservation of mass, which says that matter can neither be created nor destroyed. But in this reaction, that law is not being obeyed. Why did I say that the law of conservation of mass is not being obeyed? Take a look at the reactant side. The side where you are adding the two things together, that is referred to as the reactant side. We have one carbon atom. We have 4 hydrogen atoms on the reactant side, and we have 2 oxygen atoms. Now take a look at the product side. What we get from the reaction would be the product. We have 1 carbon atom. We have 2 hydrogen atoms. That is not right because we began with 4 hydrogen. Now we are ending with 2 hydrogen atoms. That means we have destroyed 2 hydrogen atoms going from the reactants to the product. Also, on the product side, we have 2 plus 1 oxygen, which means we have a total of 3 oxygen atoms on the product side. And again, that does not obey the law of conservation of mass. Because we began with 2 oxygen, we are now ending with 3 oxygen. That means we have created additional atom of oxygen. Now, how do we make this equation obey the law of conservation of mass? We will balance the equation. And what we mean by that is that we will place some numbers in front of the molecules. These numbers are called coefficients. So we will use appropriate coefficients to make sure that the total number of atoms on the reactant side of the equation is equal to the total number of atoms on the product side of the equation. How do I mean? Let us try to balance this equation. If we place 2 right here in front of H2O, now we have 4 hydrogen atoms because 2 multiplied by 2 will give us 4. And that is exactly equal to what we have on the reactant side. We have 4 hydrogen. But by placing a 2 out here in front of water, we will also use the coefficient to multiply the number of oxygen. And 2 times 1 will give us 2. Which means that the total oxygen on the product side is now 4 oxygen atoms. We will need to balance that on the reactant side because right now on the reactant side we only have 2 oxygen atoms. And how do we balance that? If we place a 2 as the coefficient of the oxygen, now we have 4 oxygen atoms also on the reactant side. Let us now completely check that we have done this correctly. Let us do bookkeeping. On the reactant side, we have 1 carbon, 4 hydrogen atoms, and 4 oxygen atoms. On the product side, we have 1 carbon atom, 4 hydrogen atoms and 4 oxygen atoms, which means that the total number of each element on each side of the reaction is completely balanced. That means this reaction now is a balanced equation. Let us now practice on some simple questions about what we just learned. Balance and list the coefficients from reactants to products for the following reactions. We have 2 reactions here. I would suggest you pause your video and give them a shot, and then we will do them together. Let us now work on them together. On question A, we have aluminum solid reacted with iron 2 oxide to give iron solid and aluminum oxide. The very first trick I will teach you about balancing a chemical equation is to always balance isolated elements last. Let me repeat. If you have any element that is isolated, that is alone by itself, balance that element last. So on this question A, we actually have 2 isolated elements. We have aluminum, it is alone by itself, not combined with any other element, and we have iron. We can balance either of them last. Let us begin with oxygen. On the reactant side for question A, we have only 1 oxygen. On the product side, we have 3 atoms of oxygen. If we place a 3 in front of FeO, now we have 3 times 1 for oxygen, and oxygen is balanced on both sides of the equation. Now, if oxygen is balanced, it is very easy for us to balance iron, because on the reactant side, we have 3 iron. If we place a 3 as the coefficient of iron, now iron is completely balanced. Now we are down to aluminum. On the product side, aluminum has 2 atoms. So if we place a 2 as the coefficient of aluminum, now we have a balanced chemical equation. Now there is one thing to note here. We are not placing anything as the coefficient of aluminum oxide. If there is nothing there, that means there is a 1 right there. Always remember that. And that means this is the correct answer. Let us take a look at question B. Again, we have an isolated element here, aluminum. We can balance it last, and we're going to balance it last. But there is one more trick that I would love to teach you in question B. Anytime you see a polyatomic ion in a chemical equation, you can easily balance the polyatomic ion. This is what I mean. Take a look at SO4 on the reactant side here. Now also see that you have SO4 on the product side. We can easily balance SO4 as an entity right away. This is what I mean. To balance SO4, take a look at the product side. We have 3SO4. If you place a 3 as the coefficient of sulfuric acid, which is H2SO4. Now we have 3SO4 on the reactant side. SO4 is now balanced on both sides of the equation. Now I can begin to focus on all the other elements. By placing A3 in front of the H2SO4, I now have 6 hydrogen on the reactant side. I need to balance it on the product side by placing a 3 as the coefficient of H2. I have now balanced SO4. I have balanced hydrogen. The remaining element that I need to balance is aluminum. And on the reactant side, I have 1 aluminum. On the product side, I have 2. So I just need a coefficient of 2 in front of aluminum, and I have a balanced chemical equation, which means that the answer to this would be 2313, which is this. Let us now balance some more equations. Let us begin with this one. Solid calcium carbonate. That should have a formula of CaCO3, and the question says it is a solid. If the question does not tell you whether it is a solid, liquid, or a gas, do not put it, because it is not expected that you should know. Reacts with nitric acid. Nitric acid is HNO3 in aqueous solution. To form, that means an arrow, carbon dioxide gas, that would be CO2 as a gas, liquid water, and aqueous calcium nitrate. That is the translation of the statement into equation. Now let us balance the equation. For this question, we have a polyatomic ion that appears on both sides, NO3. On the product side, we have 2 of the NO3. On the reactant side, we have only 1 of it. So to balance this equation, let us first balance the NO3 by placing a 2 in front of the nitric acid. Now the NO3 is balanced on both sides. Let us now check for all the other elements. On the reactant side, I have 1 calcium. On the product side, we have only 1 calcium. That is balanced. On the reactant side, we have 1 carbon. On the product side, we have 1 carbon. That is balanced. On the reactant side, we have 3 oxygen. We are not going to count the oxygen in NO3 because that is already balanced. So 3 oxygen. On the product side, we have 2 oxygen here, 1 oxygen here. That makes 3 oxygen. That is balanced. And on the reactant side, we have 2 hydrogen. On the product side, we have 2 hydrogen. That is balanced, which means simply by balancing the polyatomic ions on both sides, we have successfully balanced the equation. Let us take a look at another question. Balance the equation for the following reaction. We do not have any isolated element, and we do not have polyatomic ions. So this type of equation is best balanced by inspection. Here we have 3 chlorine, but on the product side we have only 1 chlorine. So let us place a 3 right here. But by placing 3 in front of the HCl to balance the chlorine, we now have 3 hydrogen. Well, on the product side, we have 3 hydrogen. We now need to balance the 3 hydrogen on the reactant side. If we place a 3 in front of the HF, now we have 3 hydrogen on the reactant side. But by placing 3 hydrogen in front of the HF, we now have 3 fluorine. Fortunately, we have 3 fluorine on the product side, and on both sides we only have 1 phosphorus. This is now a balanced equation. Let us now balance another equation. If you look at this question, you would think, oh gosh, that is so many elements. But if you look at it critically, you would see that it should actually be very easy to balance, because we have polyatomic ions on both sides. Let us begin with the SO4. We have 3 SO4 here. We have only 1 SO4 here. That can easily be balanced if you place a 3 as the coefficient here. But by placing a 3 there, we now have 3 zinc. Remember that. But before we do that, let us take a look at the second polyatomic ion that actually occurs on both sides. That is called acetate ion. C2H3O2 with a charge of -1. We have 2 acetate ions on the reactant side. We have 3 of the acetate ions on the product side. So to balance them, if I place a 2 as the coefficient for the product side and place a 3 as the coefficient here, then we have balanced the acetate ions on both sides of the equation. So what do we have left to balance? We need to check the aluminum and we need to check the zinc. Let us begin with the aluminum. I have 2 aluminum on the reactant side. I also have 2 aluminum on the product side. So aluminum is balanced on both sides. And let us now check for the zinc. I have 3 zinc and I also have 3 zinc. So this equation is balanced. Let us now balance one more equation. Now be careful with this one. It could be a little tricky. The very first thing to observe about this equation is that we have an isolated element that is alone by itself, oxygen, which means we should balance it last. Now, we have 4 carbon atoms on the reactant side. If we place a 4 as the coefficient here, now we have 4 carbon atoms on both sides. Now let us go to hydrogen. We have 10 hydrogen atoms on the reactant side, but we have only 2 on the product side. If we place a 5 as the coefficient of the H2O, now hydrogen is balanced on both sides. Let us now look at the oxygen. Let us balance it. We have 2 oxygen atoms on the reactant side. On the product side, we have 8 oxygen coming from the CO2, and we have 5 oxygen coming from the H2O, which gives us a total of 13 oxygen on the product side. How can we reconcile 2 oxygen on the reactant and 13 oxygen on the product side? The trick is to make use of a very simple fraction. If we place 13 over 2, a fraction right here, or think of it as 6.5, because 13 divided by 2 is 6.5. Then 6.5 times 2, because we have 2 as the subscript here, is going to be equal to 13, which means technically, as written right now, this equation is balanced. There is just one little issue. We do not like to use fractions to balance chemical equations. So, how can we ensure that this equation is balanced using all numbers? We can multiply all the coefficients by 2. And if we do that, the coefficient in front of C4H10 will become 2. The coefficient in front of the O2 will become 13, because 13 over 2 times 2 is equal to 13. And the coefficient in front of the CO2 will become 8, and the coefficient in front of the H2O will become 10. Now the equation is balanced, and you can do a quick check. Looking at each atom, you will see that this equation is now balanced.